Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage, Glen Ellyn, Illinois. This video today is looking at Day 14, Part 2 of the 2021 Advent of Code. The problem is called Extended Polymerization, and if you need more of an introduction to the problem, go to the Part 1 video. I explained it a little bit more in that part. So a big difference between Part 1 and Part 2. Part 1, I was using a string, like an actual string, which was getting bigger and bigger and bigger and bigger and bigger. And for Part 1, that worked just fine. But for Part 2, that's not going to work because you don't have I guarantee you don't have enough computer memory to make it work. And who knows if we will ever have enough memory to make that work. That's a lot of memory it was asking for. And so we have to mend our ways and get away from that. So I am using the methodology here of using a dictionary to hold all the different connections between the letters. So like there'd be one NN and one NC and one CB, and then from there we can generate the next generation, because we could say what goes between the NN is the C. So you're like, oh well, let's start over and say, oh, there's one NC now and one CN. And then and just keep on going through this thing and adding into it, figuring out how many there are, and then from the previous generation we can figure out the next. So say if there are 3 NNs now, if there were 3 NNs right now, and when it came to the data structure, then you would get three NCs and then 3 CNs out of it, because everything starts to propagate its way down. And so it's that idea is relatively simple. It only took me 2 hours to think it out. Of course, it's so simple, right? And so, but the problem comes into, once you have that all done, you have all the connections between the letters, you have them all nailed out, but pretty much all of the letters are accounted for twice in the way I did it. So if you have a better way to do this, I would love to know how to simplify this. So okay, so just coming back to our example set here. So I say, okay, I have 10, I want to do this for 10 generations with this data. And so you can kind of see that here are at least, hold on, let me get to here. Let me just go through all the generations, all 10 generations, and now my phrase has a whole ton of stuff, right? All of this, you can add this up and you get the right number of connections, basically, that you're supposed to get. But then because of it, there's 2 letters per. If it's the right number of connections and there's 2 letters per, there's twice as many letters as there should be. But so now what do? So you tally up all these things. Like, how many H's are there throughout all of this? Well, there's 21 plus 32 plus 32 plus, and you figure out what's going on here. And for each one of them, this is where for me the magic is. Maybe I'll mull it over, maybe my brain will figure it out while I'm sleeping subconsciously. But if I take every element, everything out of this thing and divide all of them by 2, so like all of my element numbers here. Oops, come on, element. I want to show me elements. Elements. Oh, I meant phrase here. So as I'm going through with this kind of stuff, and it takes all of this and tallies it up. That's what elements is doing right now. You'll find that 10, let me go through to down here. You will find that, there you go, you have 3,497B, 1,729N, and so forth and so on. Let me see if I can go in here. Nope, that ain't it. It's videos all the way down here. Where is my Advent of Code here? Bring it over here. Okay. Boy, come on. Okay, so there's my answers for. It's a huge number, but the idea here is coming down to here. They said after 10, there's, as I was saying, look at these numbers: 1,749, 298, 161, and 865. But for elements, for B, that just happens to be, 1749. Every odd number you divide in 2, and then you just seem to add 1 to it, and it just works out. So anything odd, anything even is just left alone. So 596 divided by 2 is 298, right? So there you go there. And then 161 is for H. And yeah, there we go. And then say the odd ones are the weird ones. So that's 864 for N. And then you add 1 and you get 865. And you take B, 3479, 3497. You get 1748, and you add 1 and you get the correct answer. And then you if all of that is right, one little subtraction will get you the same way. And so that's how I did it. This is one of those, at the moment it works and my brain isn't just can't figure out what the heck the reasoning was behind why that works. So let me put in the data real fast here one more time so you can see it definitely works in a very reasonable amount of time for something this big. Kill all these breakpoints. Start over. And then you will see, boom, oops, wait a minute, that's not the right answer. I got to do 40 iterations instead of 10. So now if I change that up, boom, there you go. In next to no time at all, you get the correct answer. So that's how I did it. I'm going to bed. I'll be sleeping in about 3 minutes. Thanks for sticking it out with me. If you have any comments, or if you know how to do things or know why the heck it works, please comment. I would love to hear it. Good sleep, everyone. I will see you in the next videos. Take care. See you then.